This is a review of acids and bases. We're going to start with what acids and bases are. There's some of their general properties. So acids always donate H+. So first of all, they have to have hydrogen in the compound, and usually we show that by putting the hydrogen first. Also, you should know that they taste sour. So any kind of citrus food has acid in it. Bases can do one of two things. They can either donate hydroxide, because the hydroxide will react with the hydrogen from the acid, the H+, and create water. So it will decrease the amount of hydrogen in the solution, the H+ in the solution. And bases can receive the H+. So either way, they're going to decrease the amount of H+ in the solution, the hydrogen ions, and that is what makes them a base. This is called an Arrhenius base. And this is called a Bronsted-Lowry base. And bases taste bitter. If you've ever had your mouth washed out with soap for saying bad words, you were tasting a base, because soaps are going to be made out of a base. There are two types of acid-base reactions. Let's start with Arrhenius. So Arrhenius neutralization reactions are going to have the same general form. They're going to look like an acid plus a base, and you're going to get water plus a salt. And when I say salt, I don't mean table salt. In chemistry, salt means any ionic compound. So for example, if we have the acid is HX and the base is Y, with hydroxide. The H and the OH are going to come together to make water. We can write it as H2O or HOH, and then whatever's left will be the salt, but make sure you put the positive one first. So I know Y is positive because it's the first one over on the left. It's in front of the OH. So we're going to put YX, then you would cross your charges and balance the reaction. The next type of acid-base reaction is called Bronsted-Lowry. And this one is an exchange of the H+. So we have an acid plus a base. The base does not have to have hydroxide for this one. And then we're going to get a conjugate acid and a conjugate base. So what happens is that the acid is going to donate the hydroxide or hydrogen ion, the H+, to the base. And whatever was the acid becomes the conjugate base. Whatever was the base becomes the conjugate acid. So you can't memorize locations for these, you just have to know that they switch. The next thing, there are 6 equations that we did to solve for pH, pOH, concentration of the hydrogen ion, and concentration of the hydroxide ion. Those 6 equations are in your reference packet. You just need to be able to use those. So it would be a good idea to practice some of these problems in the review packet we gave you to make sure you know how to calculate those. The next thing we want to talk about is strong versus weak. A strong acid or base means it breaks into ions completely. So watch for words like dissociate, which means to break apart, or you can watch for words like ionize, which means to become ions. So strong acids are going to break apart completely, which means almost 100% of those molecules will break into ions. For weak acids and weak bases, most of those particles stay together as a compound and only few of them break apart into ions. The next thing we talked about were titrations. So a titration, actually let me just type it because it'll be faster. Is a lab method to determine an unknown molarity. And we do it by using a neutralization reaction. So we're going to use an acid-base reaction, set up the titration, and then once you finish the titration, you'll be able to calculate the molarity of the thing that you don't know. And for this one, we're going to use M1V1 equals M2V2. And normally we'd have to take into account the mole-to-mole ratio of the coefficients, but for this class, the mole-to-mole ratio will always be 1, so we can take that out of the equation, and actually it's the same equation you used for dilutions. One thing I forgot to mention is the pH scale. Let's go over that real quick. It goes pretty much from 0 to 14. Can go just beyond that, but most of it's 0 to 14. We have strong acid is going to be the farthest from 7 on the low side. Strong base will be the farthest from 7 on the high side. And then weak acids will be just below 7, so acids are always going to be less than 7, and weak bases will be just above 7. So if I give you a pH, you should be able to talk about what kind of solution it's going to be. And the last thing are buffers. Buffers resist change in pH. So these are going to be solutions that it's going to be hard to get you to change the pH for these. And that's it for acids and bases.